Whenever we're factoring a polynomial, the first thing we want to look for is a GCF. So if you look at this polynomial right here, you might notice that it's not a trinomial because there's only two terms. It's also not a difference of perfect squares because 2 isn't a perfect square and 72 isn't a perfect square. But let's go ahead and look for a GCF and see if that can help us. So we're looking for a number that they can both be divided by. My coefficient here is 2. 72 can also be divided by 2. So my GCF is going to be 2. So I put that in parentheses, and then both these terms get divided by 2. So 2y squared divided by 2 is y squared. And minus 72 divided by 2 is minus 36. So now I look inside the parentheses to see if this can be factored. Well, we have two terms, so let's see if it's a difference of perfect squares. 2 is even, so y squared is a perfect square. I have subtraction, and 36 is a perfect square. So I can go ahead and factor this. I need to remember, though, as always, to make sure I rewrite my GCF on the outside. So I put 2 out here, and then I have two sets of parentheses, one with a plus, one with a minus. The square root of y squared is y, so y goes in the first spot of both binomials. And the square root of 36 is 6, so that goes in the back spot of both. Now, nothing else can be factored, so that's my final answer. Press pause and copy this down. Example 2 is a little bit more challenging. So let's look at our example. We have 36x squared. This is a perfect square because 36 is a perfect square and the exponent is even. Here I have 16y squared. This is also a perfect square because 16 is a perfect square and the exponent is even and it's subtraction. But I can't start factoring this right away as a perfect square because I didn't check for a GCF first. So I want to see if there's a number that both of these can be divided by. And not just any number, but I need the biggest number that they can both be divided by. Go ahead and pause and see if you can figure out what is the largest number that both 36 and 16 can be divided by. GCF for this is 4. It goes into both 36 and 16, and nothing bigger goes into both of them. So I'm going to put 4 on the outside, and then both of these terms need to be divided by 4. 36 divided by 4 is 9, so I say 9 and I bring down the x squared. And 16 divided by 4 is 4, so I write minus 4 and I bring down the y squared and close the parentheses. Now I look inside and see if this is still a difference of perfect squares. It is. 9 and 4 are perfect squares and both the exponents are even and there's subtraction. So I keep my GCF on the outside and I make my plus and minus. I have to take the square root of 9x squared. So the square root of 9 is 3, and the square root of x squared is x. So I put 3x in both of the first places. And then I have to take the square root of 4y squared. The square root of 4 is 2, and the square root of y squared is y. So I put 2y in both of the second places. And that is my final answer. Press pause and copy this all down. Once you're finished, you may go on to the practice. Good luck.